Welcome to conics in trigonometry. This is lesson 4.3. You should be on your yellow piece of paper. Obviously mine is not yellow. Today we're talking about parabolas. So we are only going to fill out the section of this about parabolas. First of all, some basic vocabulary. When you have a parabola, I'm just going to draw a real basic one. You already know that this point is called the vertex. I'm going to assume that's already part of what we know. Parabolas also have a point inside the parabola called the focus, and there is a line down here that we call the directrix. The definition of a parabola, it is all the points in the plane that are the same distance from the focus and the directrix. So any point on here, this is a terrible picture, but this distance should be the same as that distance down there. You can see that this graph of the parabola is terrible. But you get the idea. That is the definition of a parabola. So the vertex is always going to be directly in between the focus and the directrix. That's a little bit better on my picture. Now, we want to talk about the standard equation of parabolas, and this is a little bit different than what you're used to. We're going to go with a vertical axis because that's what we're most familiar with. So if we have a parabola that looks like this, has our focus here and our directrix here. The directrix has an equation. I'm just going to say y equals negative p. Okay, so it's some number, and it's obviously it's below the origin, so it's negative. Now, if this distance here is negative p, or it's p that direction, that means this distance here to the focus is positive p. So our focus is going to be the point 0p. Now, using that information, we can create an equation. So this is what we call the standard form, and this is x squared equals 4py. Now, we don't usually write parabolas like this. Usually we solve for y, but this particular form, it highlights that quantity p. So it's very easy to find the focus and the directrix from this. Now, we don't spend a lot of time with them, but we are also able to have parabolas that open in the horizontal direction, the horizontal axis. So I'm going to draw mine going to the right. Of course, it could also go to the left. So down here we have the directrix, and I'm going to call this x equals negative p, which means it is p this direction, which means our focus has to be right here. So our focus is going to have the point p0. That's our focus. Okay, now, we could also open towards the left, and everything would just be flipped around. The standard form of this is y squared equals 4px. So again, we don't normally write it this way, but in doing this, it highlights that quantity p so that we can graph and get the parabola based on the focus and the directrix. We're going to be doing some problems later on like, why do you even care what the focus of a parabola is? There's some very practical applications of this. Now, there's one other term we need to talk about. It is called the latus rectum. Very unfortunate name. The latus rectum is the line that goes through the focus and hits the parabola. That's the latus rectum. The latus rectum, what it does, you just want to hear me say that word more, don't you? It tells us how wide the parabola is opening, so if it's a narrow or a wide opening. And we find the latus rectum by 4p. So when we get on to our next page of notes and actually doing some of these problems, you'll see where knowing this distance of the latus rectum is really helpful. We're going to be able to graph these parabolas without plotting any points. We're not going to set up a table of values or anything like that. So this is everything you need to know as far as vocab about parabolas, and we'll switch over to the packet of things in the next video and start talking about how to use this information.